When it comes to hurricane season, we've been kind of used to a more active hurricane season over the past few years. 2020 was active, 2021 was active, and they were both kind of active from the start. Now, this year has been fairly slow. There's only been 3 named storms in the Atlantic so far this year. But the National Oceanic and Atmospheric Administration, also called NOAA, still expects an above normal hurricane season in the Atlantic. So I want to do an investigation into why. Why do we only have 3 named storms so far this year, and all 3 of which haven't really been that impressive? Alex was kind of weak, Colin was kind of weak, Bonnie was significant, but more so in the East Pacific and not as much in the Atlantic. Although it did make landfall in Central America, Bonnie crossed over Central America and really started to develop in the East Pacific. So, NOAA is still expecting an above normal hurricane season. This is their August 4th update, and this is the graphic that they put out. They have from their models, 60% chance that there is an above normal hurricane season this year, a 30% chance that there's close to normal hurricane season, and there's a 10% chance of a below normal hurricane season, which I mainly attribute to uncertainty. So, NOAA is predicting their range of named storms is 14 to 20. So 14 to 20 named storms, which is tropical storms or higher. How many of those become hurricanes? NOAA is projecting 6 to 10 hurricanes this season. And how many of those hurricanes are Category 3 or higher? How many major hurricanes will we have this season? NOAA is still projecting 3 to 5. So, out of the 3 named storms that we have, apparently we have a long way to go, and that would be correct. Hurricane season really hasn't reached its peak yet. The peak of hurricane season is right around September 10th. But during the middle of August, we usually start to see those trends start to ramp up toward that peak in early September. You can see here in the middle of August, we see sharp spikes in named storms and hurricanes on average. And that peak being in early September, but we still have plenty of hurricane season still to come. Now, Fox Weather here, which is the site that I'm using at the moment, also has kind of these heat maps for tropical activity zones for August and September. And you can see that August does have some areas of high tropical activity, including just off the coast of Florida, just off the coast of Louisiana, as well as some spots in the main development region. But if you go to September, everything just explodes on this heat map. The Gulf of Mexico starts to really ramp up. The eastern U.S. starts to ramp up, and that main development region really lights up during September. So it seems like we still have a ways to go, and Colorado State University, NOAA, both have projected above normal hurricane seasons. Just for terms of comparison, the average hurricane season is 14 named storms, 14 tropical storms or higher, 7 of those becoming hurricanes, and 3 of those hurricanes becoming Category 3 or higher. Colorado State University projects 20 named storms, 10 hurricanes, and 5 that are major hurricanes, Category 3 or higher. And we just took a look at NOAA's projections there, which these are a little off, I think by 1 on the named storms and the Category 3 plus, but close enough. So why is this? Well, within the next 9 days here, from now until the 21st, we're really not seeing much activity in the main development region, which is in between Africa and the Lesser Antilles. Not seeing a lot of moisture in this region. We're not seeing basically any low pressures. I think this is the only one that even pops up. These 2 right here. And there's a number of factors that kind of lead to this. Now, I'm using the European model for all of these anomalies and all these different models that we're going to be looking at today. So, here is the precipitable water. This is in millimeters, And we are seeing areas that have more precipitable water than others. These are kind of contributed to different air masses. So this air mass in Europe and by the Sahara has less precipitable water, less water that could actually fall than in the tropical areas, such as the main development region as of now. That's why we kind of had a disturbance just in the past few days. Now, this high pressure here, 1,024 millibars, which is very strong for a high pressure, continues to strengthen, but it's also because of how high pressures rotate clockwise, pushing this drier air mass with less precipitatable water into the main development region, which kind of blocks off any storms coming off the west coast of Africa into an area with a lot lower conducive elements in terms of moisture. And we can kind of see that more exaggerated here when we talk about the anomaly, whether there's more or less precipitatable water than the norm. So, right now, we do have lower than normal precipitatable water just off the coast of Africa. But the area that disturbance has higher than normal precipitatable water. But as that high pressure does its job, you can see here that precipitatable water anomaly here gets very strong right on the bottom of this ridge here, and you can see that kind of encompasses much of the main development region and even starts to leak into areas such as Venezuela and the Caribbean over the next few days, and actually becomes a very strong dry air mass. And then yet again another high pressure pushes in more dry air. So we're kind of seeing that cycle take place as of right now, but those high pressures in the middle of the Atlantic are kind of pushing the Saharan air layer, that Saharan dust that sometimes does reach the US. That's when the sun gets like really red and everything gets hazy, but that air mass is getting pushed slightly to the south into that main development region, which will inhibit hurricanes from really getting that strength in terms of moisture. Now, in terms of spin here, the cyclonic vorticity, we're really not seeing a lot of spin in the main development region either. We do have some spots where we're starting to see those oranges and reds, which is the more favorable spin in the atmosphere. But in terms of most of the main development region, not seeing much. Most of the spin is kind of kept up to the north where low pressures do form. But as we saw in the first model that we saw, really aren't many low pressures forming in the main development region, and this is why there really isn't much spin for those low pressures to kind of use. Then we have our wind shear. So the wind shear is going to tear apart a storm just by kind of ripping it to shreds. Now, right now, the main development region is fairly calm, but it's kind of trapped in an area of very high wind shear. This is the bulk shear from 200 millibars to 850 millibars. And you can see here that the reds, which is the higher wind shear, kind of encircles this area of blues, which is a lot lower wind shear. But eventually, this area of the light blues does start to move off to the west and actually becomes more favorable for wind shear. But just off the coast of Africa, we have higher wind shear. And I also have an anomaly for this too. The higher or lower the wind shear is, the more conducive or less conducive the atmosphere is for hurricanes. So for hurricanes, you're kind of looking for an area with more precipitatable water, a lot of vorticity, as well as low shear. And right now, the best area for that is in the Caribbean. But as that air layer from our precipitable water starts to make its way into the Caribbean, we will start to see that area that is most likely to develop a tropical cyclone start to shift more toward the eastern regions of the main development region. But we still have higher shear in that area, the eastern part of the main development region. And as we're looking at this here, that higher than average main development region wind shear is right where these waves of energy coming off of the Western African coastline is. So most of these storms come off the coast of Senegal, the Gambia, as well as Guinea-Bissau, Guinea. This general region here, we call these Cape Verde low pressures. And as they're coming off the coastline, if they are inhibited by the wind shear just off the coast, it does have the possibility of tearing these storms to shreds before they even can kind of get a grip. So that may be another reason for the fact that we are not seeing any hurricanes out of this main development region, just being that the wind shear coming right off the coast is a bit higher than average. Now, the best area for the wind shear is in this blues here. These blues are lower than normal wind shears by about a factor of 10 knots, which is very favorable, and those conditions are conducive for development, and that is in areas just north of the main development region, as well as in the western parts of the main development region and into the Caribbean Sea. Over the next 10 days, it seems like this area here generally is seeing more conducive conditions in terms of wind shear. But again, we do have to combine all of these together to form a hurricane. You need all of these different areas for everything to kind of go perfectly, right? You need water for, of course, the rainy part of the hurricane. You need low shear to make sure that the winds are picking up and strengthening. And you need the vorticity so that the hurricane starts to spiral around. And right now, it does not seem like there is just one area that has all three of these different conditions. Whether that is the Caribbean, which has low shear, but also low precipitable water, as well as low vorticity levels. Or you have the eastern side of the main development region, which has a little bit more vorticity, a little bit more spin, can have some more precipitable water at times, but has stronger than normal wind shear. So you kind of have all this conflicting environmental factors that are kind of limiting the access of these ingredients for the hurricanes to form. Now, this is just the main development region that we're looking at. There's other areas too where hurricanes can form. The Gulf of Mexico, the eastern coastline of the United States, and those aren't looking too great either. Now, in terms of precipitable water, the Gulf of Mexico is probably better than the eastern part of the U.S. In terms of this high pressure here pushing in some of that drier air mass off the coast of the eastern U.S., but the Gulf of Mexico remains fairly good in terms of that precipitable water. But in terms of from the norm, it seems like these two areas are kind of hovering right around their normals to below normal. So really not great there. Now in terms of vorticity, now the best area for the vorticity is actually the eastern coastline of the United States, as we are seeing plenty of these oranges and deeper reds here just off the coast. But we don't see that much of those in the Gulf of Mexico. At this point, it's very limiting in terms of the Gulf of Mexico. But the main problem here is the wind shear. The eastern U.S. is in the area where the jet stream currently is, and we are seeing much higher than normal wind shear in these areas. The Gulf of Mexico ain't safe from it either. The Gulf of Mexico is also experiencing higher than normal wind shears, and that is mostly because we have a trough in the east kind of bringing in, for our benefit here in the northeast as well as in the southeast, some drier air which will relieve some of the humidity. But in terms of hurricane development, not the best ingredients. closer to home in the United States, which from a residence standpoint is great, but from a hurricane season outlook isn't great. So, what do you think is going to go on with the hurricane season for this year? I expect things to ramp up pretty soon, but there is that chance, as there's a growing percentage, that we have more of an average hurricane season compared to an above average hurricane season. So, what do you think? Comment in the comment section down below, and if you found this video informative, consider leaving a like, subscribing, and hitting the bell. But thank you guys for watching and going in depth and really nerding out over hurricanes with me today. And hopefully stay tuned here, as I might do another one of these with maybe some more long range models. We'll see. But that's all I have for today. Thanks for watching. I'll see you guys next time.